Hello everyone and welcome to the channel. In this video, I'm going to introduce you to a very interesting model which has been named after the French mathematician Rene Descartes. Rene was not only a French mathematician, he was also a philosopher and scientist. Descartes is famously credited for creating the Cartesian coordinate system, which is a three-dimensional representation of points, vectors, and directions. And as you know, that is used quite extensively in all of this machine learning. So the name is quite interesting. Anyway, in this video, I'm going to show you why I think that this Rene model has far-reaching implications in the coming months. Plus, we will also be installing it locally, and then we will see what this model is. Rene is a 1.3 billion parameter language model trained by the company Cartesia. Rene has a hybrid architecture based on another very cool SSM or state space model called as Mamba-2 with feed-forward and sliding window attention layers interspersed. Now, if you don't know what Mamba-2 is or SSM architecture is, I already have covered it in great detail on the channel, so please search it out. But just to set the stage, let me try to explain what is SSM model. Just like we have transformers models, we have another architecture called as state space. State space or SSMs are models that predict future outcomes by tracking the underlying state of a system over time. They're really useful for modeling dynamic systems, forecasting, and decision making. Unlike transformers, which focus on a pattern in data sequences, for example, text or images, SSM models are more geared towards underlying dynamics of a system, predicting future states and observations. Transformers are primarily used for tasks like language translation and image recognition, whereas SSMs are suited for tasks involving temporal dependencies and sequential decision making. So, transformers for pattern recognition, SSMs for modeling and predicting dynamic systems over time. And that is where this Rene model really shines. And the size is just 1.3 billion parameter. But even with this size, if you look at their benchmarking information, the Rene is mentioned in the red bar here, you will see it is at par with most of the smallish models out there, which are mostly transformer based, on almost all of the prominent benchmarks. So you can see that in some cases it has even beaten recurrent JAMA, and then for most of the time it is at par with OpenELM from Apple. Microsoft Phi has performed really well. As you can see, it's such a good model in my opinion. Okay, so let's try to get this Rene model installed on our local system, and then we will see how it works. Before I do that, let me give a huge shout out to Massed Compute, who are sponsoring the VM and GPU for this video. If you're looking to rent a GPU on affordable prices, I will drop the link to their website in video's description, and I will also give you a 50% coupon code for range of GPUs, so do check them out. This is Ubuntu system where I will be installing it, and this is my GPU card NVIDIA RTX A6000 with 48 GB of VRAM courtesy Massed Compute. So let me clear the screen here. Let me first create a virtual environment with Conda. I'm just calling it Rene. Let's wait for it to get installed. So virtual environment is created. Let me clear the screen. And now let's install all the prerequisites. And towards the end, I'm installing Cartesia PyTorch because the model which we are going to test is a PyTorch version. And it is valid on CUDA devices. If you are using Apple, they also have an MLX version which you can get from the model card. There is a link there. I will drop the link in video's description. It took a fair bit of time, but it is done at last. Let's launch our Jupyter notebook so that we could download and play with the model in a browser environment. So let's wait for it to get launched. It seems that I am having some issues with my Jupyter notebook version with the CUDA clash. I would have to downgrade it. But the problem is that this CUDA version is required by this model. So I'm not going to downgrade my CUDA version. So instead of Jupyter Notebook, let me clear the screen and we will do it in the Python interpreter. Okay, so which is fine. Let me show you how you can do that. First up, we need to import the libraries which we have just installed, which include, of course, is Rene LM head model. Okay, so it is giving us some warning, which is fine. And then it has started downloading the model, which is okay. You can ignore these warnings. And you can see that the model size is just 2.87 gig. Let's wait for it to finish. Both the model and tokenizer are done. If I just scroll up to show you what happened when we ran that command. So we have just imported this Rene LM head, and these, because it's a new model and this library is still old, so that is why it is complaining about it. But that is just a warning about depreciation, but it is still available, so we are good. And then you can see that it has downloaded the model and the tokenizer. Let me clear the screen, and now let's do the inference with it. And now for the inference, I'm just going to use the simple pipeline, and you see that I'm just using the usual stuff where I have molded it, and then once I print it, you see the answer is totally correct. So I have given it what is the smallest country in the world, and for that the smallest country in the world is Vatican City. The answer is totally correct. Similarly, let's clear the screen. Let me test out a math equation. So I've just given it a simple math equation where I'm asking it what is this 24 minus this. The answer is 20. Totally spot on. Next up, let's ask another mind twister from the model. I'm just asking it how many R's are there in the word strawberry. The model has failed. It says 2 R's, whereas there are 3 R's, which is quite interesting. Okay, now let's try out a coding question. So in this coding question, I'm asking it to create a JavaScript function that checks if a number is even or odd. So let's wait for it to come back. Shouldn't take too long. And there you go. The code looks really good to me. It has even done the exception handling. So all in all, seems like a good model in such a small size. Now, this model is already available, as you can see. I'm not sure about the commercial side of things because it has been produced by this company, so you would need to check with them about the licensing. But the thing is that with the use of Mamba-2 and SWA, Rene has a fixed memory footprint at inference time, critical for reliably running it in resource-constrained environments such as personal computing devices. The use of Mamba-2 layers enable faster prefill times compared to other pure SSM-based architectures. So it has even offered an improvement on existing SSM architectures. So that's it. I hope that you enjoyed it. Let me know what do you think about this new model and architecture. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. Thank you for watching.